Hello everyone, welcome to the next video of C programming. In this video, we'll discuss something more about operators. So previous video, we have already discussed few operators. Also, we have written some programs related to operators. Now in this video, we'll conclude the chapter of operators by discussing some interesting operators. The first comes as a bitwise operator. Now, first of all, why the name is known as bitwise operator? This is actually used to perform operation directly on the individual bits. This is what the key point here, that whenever you are applying bitwise operator, you are applying to individual bits of the particular number. Okay. Now, what are the different types of bitwise operator we are applying? The bitwise and, bitwise or, bitwise XOR, bitwise complement, and bitwise left shift, bitwise right shift. Okay. Now, what do you mean by this bitwise and operation or operation, XOR and complement? So let us consider one example and we can understand what is the real use of this particular operator. Okay. Now, normally in mathematics, we have seen that particular bit and operation, that operand 1, then we are having operand 2, and then the resulting bit. Okay. And we are discussing about bitwise and. Okay. Now here, if the bit of operand 1 is 0, operand 2 is also 0, then the resultant operation will also be 0 after the AND operation. Okay. Similarly, 0, 1, the result will be 0 again. 1, 0, the result will be 0. And 1, 1, the result is 1. Okay. Now, what do you mean by this? Now, suppose we are given one example, 25 and 37. That means 25 and operation you have to do 37. Now already we have discussed how to convert 25 into binary. Okay. So you convert 25 into binary by yourself and represent in 8 bits of memory. For your understanding, you do for 8 bits, but originally as 25 is integer, so you have to represent in 32 bits. Okay. So 7, 6, 5, 4, 3, 2, 1, 0. Whatever may be the binary of 25, you have to represent like this. Okay. Similarly, you have to represent the binary of 37. You will also represent through 8 bits. I discussed for our understanding only you are representing with 8 bits. Otherwise, we need 32 bits. Okay. So this will be 7, 6, 5, 4, 3, 2, 1, and 0. Okay. Now here we need to do the AND operation. So how we'll do? Now there will be bits for 0 for 25, 0th bit for 37. So 0th bit will be operated with the 0th bit of 37. One bit of 25 will be operated with one bit of 37. Similarly 2, similarly for 3, then 4, then 5, then 6, and then 7. Okay. Now this is what bitwise operator means. Bit will be operated with another bit. Okay. Now out of these operations, whatever the result will get, that will also be 8-bit representation of any number. Okay. Now how you will do the operation? Based on this table or the condition, you have to do the operation. Okay. So for example, suppose here 0 is present and here 1 is present, then definitely the second bit will be 1 because of this rule only. Okay. So this is known as a bitwise AND operation. Okay. Now coming to the next one, that is a bitwise OR operator. So bitwise OR means, similarly, if the operand 1 is 0, operand 2 is 0, the result will be 0. Operand 1 will be 1, operand 2 will be 0, result will be 1. Operand 1 will be 0, result will, operand 2 will be 1, the result will be 1. Operand 1 will be 1, operand 2 will be 1, the result will be 1. Okay, this is again for the same procedure that we have discussed for bitwise AND operation for two values. The same rule will apply for bitwise OR. Okay, now coming to the next one, that is bitwise XOR operation. Okay, now here something different. Operand 1 is 0, operand 2 is 0, then result will also be 0. Operand 1 will be 1, operand 2 will be 1, result will be 0. That means if both the bits of two operands are same, the result will be 0. But if any one of them is different, that means the result will be 1. This is what the rule of bitwise XOR operation. Okay. Now coming to the next one, that is my bitwise complement. Complement means your negation. Okay. That means what? It's a unary operator. Now the operand suppose is 1, then the result will be 0. If the operand is 0, the result will be 1. That is what bitwise complement operator. Okay. So the same rule, whatever we have discussed, the example we have taken for bitwise AND operation, completely similar process we have to follow for bitwise OR, bitwise XOR and complement operation, so that bit by bit the operations can be done. Okay. Now coming to next one, this is known as your bitwise left shift operator. Okay. Now for example, suppose it is written as 25 left shift 2 means what? Let us convert 25 into binary. 1 6 0 3 0 1 1. Okay. Now if I'll represent 25 into 8-bit memory representation, 8-bit only are representing for our understanding only. Okay. Otherwise it depends on the data type, how many bytes will be allocated. Okay. So here the value you have to represent like 1 0 0 1 1. So the rest of the bits will be filled with 0. Okay. Now how many bits you have to shift? You have to shift 2 bits to left. So that means here this leftmost, every bit I have to shift 2 bits left. So wherever the two leftmost bits are there, they will be out of the scope. Means what? Now this 0 0 will be out of the block. Okay. And what will happen? If I'll represent everything, now you have to start from this number. So 0 1 1 0 0 1. Okay. Because these two bits, the leftmost two bits, because it's a left shift operation, and how many bits you are shifting? 2 bits. So the leftmost 2 bits will be out of the scope. Okay. Now what about this vacant one? You have to fill with 0. Okay. The same process you have to apply for right shift operation. Suppose right shift 2 bits we have to do. Okay. The same thing. What I will do? First of all, you have to represent the numbers in binary. So how to represent? 0 0 triple 0 1 1 0 0 1. The value whatever I have got here, I am just representing here. So 5 4 3 2 1 0. What I need to do? Right shift operation. So if I am doing right shift operation, that means the rightmost values. Okay. The rightmost values, two values will be out of the scope. That means in the resultant, Let me draw here only. Okay. So these two rightmost bits will be out of the scope. Okay. Now every bit will be shifted to 2 bits right. So you have to write this 0, which is at the second bit, will be at the beginning. So 0, 1, 1, and triple 0. What about the rest? You have to fill with 0. Okay. This is what my right shift 2 bits, and this is what my left shift 2 bits. Okay. And these are actually applicable for the positive numbers. To represent the negative numbers, it depends on the system. Okay. So it completely depends on the system. The result cannot be predicted. Okay. So in bitwise operation, the most important thing, they are actually directly applied to individual bits. That's why it is known as a bitwise operator. And for all different kinds of operation, you have to go, or you have to apply the operation to every bit by bit of operand 1 and operand 2. Okay. Now coming to the next one, which is a size of operator. Now this is very special operator because it will determine the size of every data type in bytes. Like we have discussed in previous videos, the size of integer is 2 byte or 4 byte depending upon the operating system. Float is 4 byte, character is 1 byte. But how will sure about that? Okay, so you can use this size of operator which will represent the bytes in integer format. Okay, so let us write down this example so that we can understand easily. Okay, so I'll start with main. I'll declare just different types of value. Okay, so 4 different types of variables I have declared, and right now I need to print the size of every data type. And I have told you that the size of operator will always give a number which is actually integer one. So I have to represent the format specifier percentage %d for everything. Okay. We will not write percentage %c here. Remember, because size of operator will give a number, and that number is a integer data type. So we are writing percentage %d for printing the size of every individual data type. And finally, we'll print the size of double. So don't be confused with the format specifier percentage %d. I am again repeating, percentage %d we are writing only because you are printing the size of the data type, and size of will give you a simple number, and that number means integer. Okay. No warning, no error. Now you check. Size of integer is 4 bytes, size of character is 1, size of float is 4, and size of double is 8. Okay, this is how the use of size of operator will come into picture, because it will print the size of every data type on a particular machine. Okay, now coming to the next one, that is my increment decrement operator. What is increment decrement operator? It's a unary operator first of all, because it is applicable to a single variable. Okay. Now, whenever you are applying the same thing to a single variable, what it will do? It will increase or decrease the value of the variable by 1. Okay. And in increment, we are having pre-increment, post-increment. In decrement, we are having pre-decrement, post-decrement. But what is the meaning of this particular statement? Let us understand through example. So let us understand for increment operation. The same is applicable for decrement operation. Integer number equal to 10. Okay. So I am printing the value of number. Done. I am writing number equal to number plus 1. Okay. Number equal to number plus 1. And again I am printing the value of number. So what will the output? Number will be 10 first of all. After plus 1, number will become 11. See, number equal to 10, number equal to 11. So what do you mean by number equal to number plus 1? That means you are incrementing the content of number by 1, and then the same value you are assigning to the same variable number. Now in this case, okay, in this case, we can write number plus plus. Okay, this is known as your increment operation. Okay, now let us check. See, number equal to 10, number equal to 11. That means number equal to number plus 1 and number plus plus both are similar. Okay. Now the same thing I can write by putting this operator previous of the operand. Okay. Let us check what will happen. Same output you are getting. Okay. That means if I am giving this particular plus plus operator before the operand, is known as your pre-increment. And if I'll give the operator after the operand, that is known as your post increment. Okay, this is only the difference. If I am giving the operator before the operand, it's known as your pre increment. If I am giving the operand after the variable or the operand, that is known as your post increment. But in both ways, the number is incrementing itself by 1. Now comes the question, what is the difference between this pre increment and post increment? Okay, so I am taking the help of another variable. I am writing result equal to number plus plus. Okay, okay. Let us first use pre-increment. Result equal to number plus plus. So here, along with the number, I am printing the value of result also. Okay. Now let us check what is the output. Then we'll discuss the mechanism. Now here, number is 11 and result is also 11. Now that means what? Now first number is incrementing itself by 1 and then it is assigning the value to result. Means first increment yourself and then assign to the left side. Okay, this is what the meaning. Then so let us make it comment line. I'll write result equal to number plus plus. Okay, let us check. Now see, number is 11 but result is 10. That means how the result is getting 10? Initially number is 10 because number we have assigned 10. So that 10 it is assigning first to result, then it is incrementing itself. Means if it is a post increment, then first assign to the left and then increment yourself. Okay, this is what the difference between your pre-increment and post-increment. Now everyone can do one thing. You can rewrite the same example and test by yourself. कि what do you mean by pre-increment and post-increment? Once again, pre-increment means first increment yourself, then assign. Post-increment means first assign, then increment yourself. And this is completely similar to the decrement operator. If it is pre-decrement, then first decrement yourself, then assign. If it is post-decrement, means first assign, then decrement yourself. All of you do one thing, just copy the same code and write it again with minus minus operator or decrement operator. Okay, so this is what actually the unary operator works. Okay, so through this video what we have learned, actually we have learned how to do the bitwise operation, how to find the size of any data type, and how to convey or how to operate the increment decrement operation on a particular variable. Okay, so thank you everyone for watching this video.